WaveTalkers Live. This is episode 54. Today we are kicking off a brand new series called our Maker Series, and today we're going to focus in on GoBox Design. My name is Chris Mattia. My amateur radio call sign is Whiskey 6 Alpha Hotel. I'm joined by my esteemed colleagues Dan NR6V and David W0DHG. And we're going to get right into it today. We've got a lot of exciting things. We even have Steve Waterman here for a brief announcement. We're going to look at that at the end of some exciting new news coming out of the Winlink team as well. But before we get any further with that, let's go ahead and do our regular Winlink check-in. So if you have access to Winlink, go ahead and send in a Winlink check-in. We'll step through the process here in just a second. Send it to all three of our call signs, W0DHG, NR6V, W6AH, and our tactical call sign, WaveTalkers. In the comments field is a place for you to let us know what is your must-have feature of a GoBox. So let me go ahead and do the whole, actually, Dave, if you can unpin you and Dan real quick, and we'll switch over to the walk up here, take that off screen and maybe put me down in the corner like that. That looks a little bit better. So if you've got your copy of Winlink open, make sure you quit Winlink and launch it again, because there's a new version that just came out, especially if you're operating with the beta version features turned on. There's some new features that would be possibly up here in this area of the screen. We'll have a look at those in more detail near the end of the show. But in order to send in your Winlink check-in, go ahead and click on the new message button up here. And you're going to go ahead and select a template. If you made any of the shortcuts previously from some of our previous episodes, you may have a shortcut right to the form right there. I'm going to go ahead and click the select template. I'm going to click the little plus next to standard templates, come down here to the area that says general forms. And in the general forms section, we're going to come down near the bottom, and there is your Winlink check-in. Go ahead and give that a double click. If the demo gods are with you, it should open up your web browser of choice and should bring you right to the form. Go ahead and fill this out. Make sure you click on the date and time so it updates with the current date and time from your computer, and all of that information gets plugged in there correctly. You want to make sure you select the status. This is a exercise, and select the band and the mode that you're going to be operating from. You can put the send to. This is where you'd put all of our call signs. Again, if you watched that previous episode where we talked about power user tricks for Winlink users, then you probably have a shortcut here to send to, and you can just enter in live in that port, and it'll enter in all of our call signs. If you didn't do that, go back and watch that episode. I think it was 52, maybe 51, 52 was the episode for that. Anyway, you're going to fill in the rest of this information. Here's the comments section right there. That's where you're going to let us know what is your must-have feature of a GoBox, and you go ahead and submit that form. When you do, it'll fill in all the information here. You just post that to the outbox and send it like you normally would send any other message with Winlink. I'm going to go ahead and click the open session button, click start here, and we'll see if we have any messages coming in. And it looks like there are quite a few of them that are coming in here. So I'll go ahead and download those. Near the end of the show, we'll go back in and we will check, and we'll bring up a map and see where everybody has sent in their check-ins from on the map to make sure everybody was able to get that in. So with that, let me jump back over to the slides, and we're going to kind of walk through a little bit here about GoBox design. How do you go through and design your own GoBox? And we're going to look at a bunch of different design process, and we're going to look at some different ways that you can model your next GoBox that you're building. But we're going to start off by having a look at my first GoBox and learning from my mistakes, the things that I completely screwed up in the process of setting this up. So move that a little bit over there. And first of all, I got my inspiration. I was surfing around. I had looked at a couple of different ideas, but I really zoned in on this idea of these battery boxes. It wasn't exactly this one here. This one is a kind of a newer model of it, but I got this idea of like, I really like the field boxes that had all the ports in them for the battery components in the top and power components. And so I just kind of got it locked in my head that's what I wanted to be able to model and to be able to do. So rather than really kind of thinking through the process at all, I went out and I picked up just one of these little field boxes or plastic ammo cans. I took the radio that I already had, the battery that I already had, and for about a year and a half, that's what I used as a GoBox. I just put everything in it, carried it around with me. I switched up what things went in the box because I was trying to figure out like what actually fits, what doesn't fit, but I didn't do it very scientifically. I just kind of like threw stuff in the box and carried it around. It worked, but every time I would go to set up and operate, my setup would look something like this. Like everything would have to come out and I would have to set up everything all over the desk. It was nice because I had everything together in one spot, but it wasn't very efficient. So then I thought, hey, let me go ahead and design this out. And this was my entire plan. I just opened up a copy of Adobe Illustrator and I sketched out what were going to be my components on the top. I was going to have a main switch over here. I was going to have some little power ports on there. My big integration plan was that antenna port there on the top and maybe a USB port over on the other side. But this was pretty much the extent. And so I went right from this idea that I had to, well, let me get in and start making it. So I took the lid to the plastic box that I had. I got a utility knife and just cut the little supports out that were all over in this area just with a utility knife. I drilled some holes and plugged in the SO239, and I immediately started running into problems. All of my little port connectors here, turns out that the plastic wasn't really strong enough to hold them because I didn't have the right size bit for drilling the hole in them. And so I had to go get a piece of scrap wood and put it as a backer board. The switches that I bought, I didn't do a lot of research on those beforehand. And turns out those were underpowered for the current draw that I was using. And so I've burned up a couple of these in the process. But ultimately, hey, this is what I came up with. And it worked fairly well for me. I was really happy with the way that it kind of turned out. At first, I had access to USB power, a 12-volt socket connection, and some power poles up on top. I could plug in my antenna connection over here on the side, and I wired in this extra switch so I could turn on the radio or I could turn on the power bank here. And I was really excited that this was all coming together. But I quickly found out that I didn't know what I didn't know, and I rushed to a solution. I tried really hard to just go ahead and get something thrown together in order to make something functional. Kind of a typical thing that a lot of us hams would do. Some of the problems that I ran into right away were sound and heat issues. It turns out if you take your radio and you put it inside of a box and you close the lid, it doesn't let the sound out very well. And so it became really difficult to be able to hear the radio. So one of the first things I had to do was punch another hole in the top and run out a headphone cable so I could then plug in a big old external speaker, and I ended up carrying around this big giant external speaker all the time so I could hear the radio. The other issue that I ran into right away was the heat issue. When you take your radio and you put it inside of a closed box, if you don't think through and put air vents in the thing to allow the hot air to come out and allow some good circulation, your radio gets very unhappy pretty quickly. So these are just a couple of the issues I had. I also found out that my setup that I was using, here's my GoBox back here in the corner, was really messy and really inefficient. I was constantly having to open the lid to the thing and start pulling the radio partially out. I ended up putting Velcro on the front to be able to Velcro the head unit onto the front of it. Anytime I started operating any digital modes, I'd have to take the signal link out of the box and pull it out because I didn't have enough room for having that mounted. And so my setup would just kind of like grow over the desk space that I had available to me. And if you look at this image, I've got my GoBox setup here juxtaposed with a more professional looking, much more cleanly designed kind of setup. And one of the challenges that as hams we face, if we do get deployed and we go to, say, EOC, or we go to our served agencies, and we're starting to work with professionals, we need to be able to look the part as well, not just be able to operate, not just be able to get the message through and pass it, but we have to be able to be taken seriously when we're set up and when we're operating there. And by just having gear that just kind of spews out all over the place, that's not efficient, does not lead to the confidence level that the professionals are going to have in us as ham radio operators. So let's step through a little bit of what the design process is, and just talk just a little bit about what that process looks like that you may want to step through as you're designing your own GoBox in the future. The first step is always to define the problem, and you want to be as specific as you can with this problem definition. You want to make sure that you know what your goals are and what your overall parameters are. Next, you're going to start collecting some information. You're going to do some research into the area that is surrounding this problem that you've defined. It may be going out and looking at other GoBoxes. It might be going out and researching what types of antenna connections you may need, or what type of audio headphone jack switches in order to make a speaker and headphones work seamlessly together. You might need to do some investigation into the battery that you're using to determine whether or not the battery that you've got inside of your box is going to support your particular radio. You really need to collect a lot of information and really kind of do your homework about the overall process to really get a grip on it. Next, a great step is to brainstorm ideas. Just working in a vacuum, you by yourself, is going to lead to a lot of problems. You want to connect with other people who have done this, who have worked through some of the processes. You want to connect with people both in your own group and outside of your own group. One of the challenges a lot of times that we have as hams, we're working on our own. Well, maybe we'll reach out to the folks on our own team that we're working with, or within our own club, and everybody within the club is starting to generate all the same ideas, because it turns into a little bit of an echo chamber. You want to make sure that you add a little diversity to that, reach outside of your group, get some additional thoughts and ideas from other areas so that you can come up with a solution that's going to work specifically for you. Next is going to be develop models, prototypes, various different solutions. And the more you can model out what that actual solution is going to be and be able to test that solution and analyze those results, the better off you're going to be. It's a real iterative process of going through and trying to get really precise in how the different components are maybe going to interact with each other, figure out what really is needed inside of that box, and test how the different components work together. Some of this can be done, we'll look at some different methods of being able to do this, all extremely low cost, and well, basically all pretty much free with the equipment that you already have there. So then you want to test and analyze all of those results, test those models, really kind of push at it a little bit, figure out what's working, what's not with it. You want to improve and refine that model. Keep just checking it, come up with some other little modifications to it. You may find that this leads you back to redefining the problem, revising that initial thought that you had for whatever the problem that you're trying to address. And you're taking all of this information into account. And you just keep iterating through this loop as many times as you need. Another component of this design process is you can oftentimes go back to a previous step, because you get in and you find out, hey, I was testing this particular thing. Let me just go ahead and tweak the model. Or you've built a model, you've done some tests, you've done some improvements. You know what? Let me go back and brainstorm a little bit more with some other folks that may have encountered this problem before and are able to help me work through this. So this is the general design process that we're going to now step through. And that all starts with defining the problem. So the problem we're trying to solve is to design a self-contained portable radio station capable of efficiently passing voice and Winlink traffic. Now that's my goal. You may have different goals for your particular GoBox that you're trying to define. We're not even going to get into the whole, what is it called is it a GoBox? Is it a drop box? It's whatever the kind of kit that you're putting together to take your radio station out into the field to operate with either partner agencies, served agencies, operate in an EOC just with your team or so forth. The key components that you know you're going to need, even with just this definition, you're going to need a container of some kind. We'll call it a box for right now because that's a pretty generic way of thinking about it. You're going to need your radio, or a radio that's appropriate for the type of operating that you're doing. You'll need some kind of power source. More than likely, you're going to need a battery, but you may want to think about how you're going to operate short-term, long-term, so forth. Microphone for being able to do your voice communication, some sort of audio interface between your computer and the radio, obviously your computer and an antenna. So these are kind of like the core functionality pieces that you need to start thinking about that you've got. So let's do a little bit of research now and start thinking of, and start looking at what some of the other GoBoxes and GoBox designs that are out there. And when I first started getting into this, I ran into this one. This was designed by a colleague of ours here in Southern California, and it's one that really stuck with me. It's in this really nice. It's a vertical kind of small Pelican, kind of like a file folder kind of box. It's all completely self-contained. You've got the VHF, UHF radio that's in here, signaling for doing digital with the USB port right there in the front. It's really easy to be able to access. Over here, this is a fan that allows for cooling and airflow. You've got a speaker that's over here, so you're able to hear it. There's actually another fan that's back here, so you've got an intake and an outtake fan. I'm not sure which one is which. You got fuses, a little antenna port that's up here, some various different other connectors that are available. There's even a little light up here in the lid. It's a really nice, clean design that was very well thought out. There's even handles, so you're able to grab the top portion that has all of this top panel and lift it out, so you've got access to all of the gear. So you notice there's not holes that are drilled in the side of the box. So all these are different considerations that you may want to incorporate some of these into your own design. And that's just one idea. Another GoBox, this one actually was designed by our colleague, David, W0DHG. This is one that's done out in a rack-mounted system, oftentimes a Gator box, or there's other different brands that are out there. And here he's got the his radios. He's got the antenna tuner that's over here. There's a signal link down in here. There's a speaker. There's more equipment that's back inside of this area, but it allows them to just drop it onto a table and be able to set up and operate pretty effectively and pretty efficiently, kind of right out of the box, if you will. So as you start looking at these, he's also got his computer to be able to do the Winlink traffic, and I assume this kind of fits inside of the box. But I'm not positive of that. Anyway, so that's one. So then as you're doing this research, as you're starting to look through some of these other different components, more questions come up. How are you going to transport this GoBox? Those Pelican case, or the rack mounted cases, very quickly get very big, very heavy, and become very difficult for an individual operator to be able to easily transport them. How are you going to operate this? What is going to be the flow of setting up your particular gear and your particular set of operating procedures? How are you going to do that with the box? How are you going to interact with it, and so forth? So that brings up the thought of, well, does it have to be a box? Well, not really. Some Go bags, Go kits can be a backpack. This makes it really easy to be able to throw the gear on your back, and hike into a location. That may be the right approach for you and the particular problems that you're trying to solve. Here, this operator has a small portable mast that they're able to use with their radio and the different components that are in here. And it looks like they're using mostly HTs for the radios that they've got here. Another option, dump all your stuff in a box and carry the box with you. Now, this approach definitely works. This one's been modified a little bit. You can see there's some different like through hole components that are on here for the antennas. And but otherwise, it's a lot of gear that's kind of like all self-contained. This is kind of what I was doing for a while in the beginning, putting everything in just one box, carry it with me, and then worry about what kinds of things I needed to set up when I got out in the field. And I will say, we did an exercise last fall, and this was one of the experiences that really keyed me into this, hey, I need to redesign this whole GoBox that I have because it's not working. I showed up and I needed to get on the air quickly, and I spent a lot of time pulling all the gear out and trying to rehook it all up and make sure everything was working again. It was not very efficient as a way to operate. Another consideration is, what does it look like when you open up your Go kit and you set up and you take over a little bit of space, maybe at an EOC? If you're working with professionals and they walk over and they see a setup that looks like this, it's not going to instill a whole lot of confidence that that you really have all of your gear together in a nice way. It doesn't provide the same amount of the same kind of experience that, say, a setup like this is going to do. Look how nice and clean this looks. You've got a very professional, clean setup here. You've got the radio, you've got your signal link, the speaker in here. There's access in this particular GoBox for getting on a mesh network, and so the networking port is right out here in the front, and so forth. So really kind of thinking through the design of how you plan to operate, how you plan to transport it, what is the specific equipment that you need, and start to think about those design processes. So now we've done our research, and that's informed our choice of our definition of the problem. So I've refined this a little bit. I've come out and I've said, let's design a compact, self-contained, single-person portable radio station capable of quick deployment, transition to a sustained operation, so we can go from short-term to long-term operation, efficiently passing voice and Winlink traffic. So this is the definition that I'm working from for my particular GoBox. This is what I'm trying to design. So the next step in our design process is to brainstorm ideas. And for that, I want to bring my colleagues back up because they have a lot of experience in building GoBoxes and implementing them. So let me bring Dan back up to screen. Let me add Dan up there, and let's add David. And
did it.
Oh, you already did. Great, thanks. And as I've been kind of working through this, because I'm not starting off from scratch, I'm kind of rebuilding this a little bit. Let me actually, what kind of ideas do you guys have kind of getting started for the GoBox stuff?
David?
Go ahead, Dan.
You know, I've been through an evolution in doing GoBoxes, and I've sort of gone from everything in one box to more of a modular concept, because I found that the all-in-one box got to be clumsy. It was not as flexible as I thought it would be, and I'm carrying a lot of things that I probably don't need for any given event. And so I've gone more to a modular concept where I gather what I need for that particular event. And anyway, that's sort of my evolution in thinking, and also sort of building things that are flexible, that are easy to adapt if I need to make changes, or there are changes in my thinking about how things get done. So,
do you have some examples of some of the boxes that you've built?
I do. Let's see here. The first one I started. I'm having trouble with my mouse. I've got too much going. Okay, this is the first one I started. This is just a Harbor Freight. I guess it's a toolbox. It is sold that way. And I started this one first, and it was one of the last ones I actually finished. And in a minute, I'll show you why. But I've got my ports coming out the side for antennas. I've got a fan, sort of cross ventilation in it. You can see the other side. One side has a fan, one side is just an input port. I've got a AC power input switched, and I've got my power poles. One set for charging the internal battery, and one set for operating if I have external power. So this is the internal part of it. And one of the reasons why it took me so long to finish this is I had to cut the faceplate to fit the radios. And I didn't really have the proper tools to do it. And the radios, for the most part, don't provide a lot of coverage. If you make a mistake and cut the hole a little too big or whatever, it doesn't look good. So that took me a while to complete. But as you can see, I've got 3 radios. I changed out after a while and put that 8800 Yaesu in there, which had a remote mount faceplate, which made the process easy. I didn't have to cut the face or cut the plate to match the faceplate. Oh, David, we definitely have got to get me a computer with more memory. This is real laggy.
We're working on it.
Yeah. Yeah, my cursor's just not allowing me to jump. Here's a side view. The beauty of this GoBox, and why I still like it, even though I've sort of changed my opinion on things, is that I can set this up. It has a small internal battery. It has a telescopic antenna you can see in the picture there. So I can set up and have that on the air in 2 or 3 minutes. And that buys me time to set up external antennas, external power, things like that more at my leisure. But I'm on the air and monitoring and working in a very short period of time. The next thing I went to, which we've talked about, is the Gator box concept. What I liked about it was, and excuse the mess, I actually used this morning for my simplex net and didn't have time to dress it up for you. But the idea of the Gator box, to me, that was so advantageous was it's very easy to swap out radios. If you have a radio that fails, or you come up with a better idea of what radio you need, it's very easy to swap them out. The shelves are rack mounted. I use they call them perforated shelves that have holes in them. So you can even zip tie a radio to the shelves. It's very easy to change them. This particular one has, on the upper left is a GMRS, Midland GMRS 40-watt mobile. I have my antenna tuner. Below that, I have the FT857 kind of all-band radio. And on the left right now, I have an older scanner in there. So the Gator box idea is very flexible, and you can buy these face plates that are just blank plates, and you can drill them out to add your accessories, etc. So that's a good idea. But as Chris said, you can really go overboard really quickly with those and end up with a really heavy box that's a little bit hard to transport. Here's a shot I sort of snuck in from the back. Again, I used a blank, I think that's a 2unit plate that I have my fans and my antenna connections. It's all real neat. And when it's set up right, it looks really slick, but it's not very flexible if you need to make any changes. So then I sort of went to this idea of having, again, we're locked up here, sorry, of having a modular concept. And that's where I went to the ammo boxes. This is a 50 caliber ammo box. I think I got this one at Harbor Freight. And this is a purpose-built radio box. It's got an 800 megahertz radio, which is for our fire department. It has a speaker, and I built a little plate there that has a 12 volt external. It has a fan, switch for the fan, a voltage meter, and a couple of fuses. So very simple. And if I don't need an 800 megahertz radio, it doesn't come with me. A lot of our facilities have the 800 megahertz radios at the facilities. And if I'm going there, there's no point in dragging that along. There's a little more of a close-up for the box. And here's the side view. Man, this is not cooperating. You see the fan. I have my power poles. That's a neat little way of mounting power poles in a panel. It's just a couple of little metal clips that slide in, lock the power pole panel in, and you put screws in. Have an N-type connector on that because that's what the 800 megahertz, it's an old Kenwood commercial radio that I'm using there. And if I can get the cursor to move. Well, you get the idea. The ammo boxes work great. You can get them in plastic and metal. The tops come off. I actually stick the top underneath the front of the box, which gives me a little bit of an angle, so it's easier to see the display and work with. And I've got one of these for VHF, UHF. I've got one for GMRS. I'm working on one for 220. So you grab what you need and you go. And my thinking on batteries now is an external battery box that I have a couple of them with different size batteries, again, depending on what my expectation for duration of the event. So that's what I've got. I'll go back to you, Chris. Chris, you're muted.
There we go. So you're not putting an internal battery inside of the small EmComm boxes that you're using now?
No. Space is pretty tight. And like I say, external box gives me a little more flexibility, and they're so easy to carry, unless you're carrying a whole bunch of them. It's just as easy to have the battery box, and I can run multiple boxes off a single battery.
Right. That's a good idea. How is building out the metal boxes versus the plastic boxes? I know the metal boxes are going to be a lot more durable, but what kind of tools?
I mean, it's a little tougher to cut the box, drill the box. Plastic's nice because you can do a lot of it with a utility knife or a Dremel. I tend to use on the metal boxes, I tend to, even for rectangular openings, I drill the corners, and then depending on how big the hole is, I can either use a Dremel or I've used those vibrating multi-tools, work pretty nicely. And then I use files to clean the holes up. I cut them a little small and use a file to pull it in nice and tight. I think that works well. But it's a little tougher. The biggest problem with the plastic for me is it's real easy to cut it too big.
What when I know you have a 3D printer, are you making any internal mounts for any of the equipment that you've got, or are you just using off-the-shelf brackets, or how are you mounting the equipment inside?
I haven't used it yet. One of the things that's been a problem for me, and you've helped me with this recently, is I've not learned how to use the 3D design software. And now you've started to teach me that. And I think that may be something we have upcoming here that really gives me flexibility to now be able to model stuff. Up to now with my 3D printer, I've been limited to, somebody else's designs that I get off Thingiverse or one of the other sites. And so having the ability to design my own stuff, that'll be huge. And yes, I definitely would use that in future builds, because that really, it allows you to make it look really good. And also, like you say, gives you the ability to mount maybe with fewer holes to drill through the box, fewer exposed fasteners, be able to do that. So 3D printer could be really big.
Awesome. Hey, let's go over to David, W0DHG, and let me bring you up. I'll just go ahead and replace you up on the spotlight. What kind of input do you have?
Well, let me share my screen.
I know you're working on some big projects right now.
I got a bunch of stuff going on, so let me share my screen, and I'm actually going to share some sound too. Let's hop right into the PowerPoint. See it? Let's see. Can you see my screen?
Yeah, we see
Yes.
WaveTalkers live, GoBox Design.
Great. Okay. So this is kind of my first GoBox, and really, focused on what's the mission. And when I first got involved in amateur radio, and again, I built this box in about 2013, almost 10 years ago. I worked with the local Aries group, and the local Aries group, our mission was serve the local hospitals. And for the most part, I started with the rack mount box, partly because the box that you guys see here and its mate, which Chris showed you earlier, that has a different radio in it. They were the right price, which was free, and was able to get them and add some shelves. And as you see here, I had 4 radios in there. Actually, the HF radio there, when I first put this together, there was a Citizen band radio there. And this box covers, the upper left is a FT 7800 at 2 meters 70 centimeters. The right top is a Linko 220. The bottom left is just a straight 2 meter FT, I think that's a 2900. And then again, there was a CB, and now the radio that's in there now is an Linko HF radio, 6 meters through 160. And for a long time, it worked really well. It was very flexible, and gave me lots of options. Actually, it starred in a I can find my. It starred in a episode of
Southern California
News.
ham
Can you hear
radio
that?
operators put their skills to the test today.
W0DHG, WA6VHA, you are loud and clear, sir, in Sunland.
Today's event at Pierce College in Woodland Hills is part of a weekend-long demonstration for the Los Angeles Amateur Radio Emergency Service.
So that was a deployment, and as you saw there, when I deploy this radio, most of the time it's just going to sit in the back of my truck or on a table next to it. It's not something that I'm going to carry up a long hill or far away. It's meant to serve the hospital where it is. Most of the time we plan to work out in the parking lot. We don't want to be in the way. We'll always have communications with the ED and the emergency manager at the hospital via handy talkies. And this works great. It worked really well for a long time. In fact, it's still sitting in my shack. and I use it for weekly net check-ins. Working on some other projects right now, as Chris alluded to, working with a local nonprofit organization that's a Fire Safe Council. It's a California thing that helps the local community prepare for fires and be ready to go. There's 2 iterations of these boxes that we're building. This wasn't my first choice of the way to go, but they wanted something small, portable that would be able to get up and on the air for a short amount of time, but very quickly. So we're building out of these PowerWork boxes. And the one you see on the left, that's a Yaesu 2 meter, 70 centimeter radio. They're both in progress. Neither of them are anywhere near being done, but we're in the design process that Chris is going to walk us through in a little while. That one's meant to be deployed with a laptop. It gives you voice communications as well as Winlink and other digital capabilities. The box you see on the right, that one has a 2 meter radio only and a PC, the little box that you see next to the battery there, that's a puck PC. And this one's specifically set up to be a Winlink digipeater or a Winlink gateway. We can deploy out where we've lost communications, but give us the ability to have some of the operators repeat through a box that's set on a hill higher up to allow us to get onto the network of gateways we have here in Southern California. So these are works in project. We'll keep you up to date on those as we go forward. And coming soon, I did acquire a smaller Gator box. The one I showed you at first is a full height, a full rack size. And the box you see in the back there, that's the one that Chris showed you that has my HF and UHF radio in it. The one in the front, that's a shorty. It's smaller. That's something you can carry on. It's carry-on size. And I plan to move the first box, the one that I showed you in 2013, move all those radios over to that. It's going to include some notes that I have put together on this. Is we're going to include a puck PC. When Chris talked about the GoBox that he showed you we used for the shakeout, there wasn't a PC, and we used the PC, the laptop that was sitting next to it, and it does fit inside the case when we carry it. But the next iteration, the one that I'm putting together, there's actually going to be a puck PC that lives in the case with the radios, as well as a small Microtech HAP AC Arden node. And by plugging the PC into that Arden node and turn on the local Wi-Fi, you'll use a separate laptop that you can use as a Winlink client to control the PC that's in the box that you can set up as a gateway or a digipeater or to do other things like Squawk APRS. It gives you a lot more flexibility. It gives you more ability for other folks that might not be sitting right in front of the radio, but they need access to be able to send out through the radio that's a dedicated Winlink station in that box to just connect to it via Wi-Fi. So lots of things, lots of concepts going on. And I know Chris wants to jump into the next session, so I'll throw it back to him.
Thanks, David.
Yeah.
Where's the replace the spotlight button? There you go. All right. So that's all of that's really good information to be able to have as we're starting to think through the next stage of being able to do the design process. And the next stage, whoops, wait a minute. I got to have the right thing that's showing up here. No, I want, oh, not the walk up. I need the slides up there. Huh, interesting. Okay, so things are a little weird for me. Let me turn that off and we will bring, slides should be up. 5. Oh, I have somehow gotten out of my slides. There we go. And we'll move down here into the corner again. So now we're going to start getting started with modeling some of these different ideas. And when I start thinking of modeling in the design process, we're taking all this research, we're taking all of the ideas that we've pulled together, we've taken the brainstorming that's come into effect, and we're going to start laying out some different sketches for how we might want to design our next GoBox. And I literally, when I'm doing this, oftentimes I'm literally doing it with a piece of paper and some pens and some markers. You can see my wonderful ability of an artist here coming in, and you can see how I've got the faceplate laid out. I'm starting to think through some of the different components that I've got here. Nothing is drawn to scale. It's just quickly sketching out ideas, and I might go through an entire stack of paper as I start sketching out different ideas. This is one of those super low cost ideas to be able to start coming up with what's going to be the next overall design that you're going to implement. Once you get some of those ideas that are kind of flushed out to the point where you think, hey, this may be the direction that I want to go with this, the next stage is to go ahead and start building out some scale models. And the approach that I'm using a lot of times for building out my scale models is to literally take maybe an old Amazon box that's just shown up at the door. I'll open it up. I'll take the different components that I have, such as my radio. I'll lay it out on the cardboard and just grab a marker and kind of trace around the outline of it so I can start to get a sense of the overall scale. One of the problems I keep running into is if I'm using a small box, such as this is the box that I'm going to adopt for the next GoBox build that I'm doing. It's just a small little plastic box. You can get these on Amazon. I think this was about $15, so super cheap. Is making sure all of the gear really fits inside. That sketch that I had, if I really look at this sketch, it's clearly not to scale at all. And so I don't really get a good sense of what is really going to fit inside of the box, what's not going to fit, how are the components going to line up, are the ports going to all line up. And so by simply taking and doing this little tracing exercise where you trace out the outline and then get some just cheap rulers. I think this ruler was $2 on Amazon. This is a real nice tape. This is one that W0DHG suggested, and it's a seamstress tape. These are real nice because they're super flexible, so you're able to quickly get measurements. I really would suggest adopting to do all of your measurements in millimeters. It's a whole lot easier than dealing with fractions. I don't know how you enjoyed fractions when you were in school, but I really didn't enjoy trying to calculate out 7/8 and add a 1/4 inch to it and all. It gets too complicated way too fast. It's much easier to just get close enough with some of the general measurements with using a tape like this. So my tools for doing this are literally pens, paper, some markers, pair of scissors. I can go through and cut these out, and then I can literally lay them down inside of the box super fast to be able to start getting a sense. And I'll lay out things like I'll take the faceplate for the radio and I'll trace the bottom of the faceplate so I get a sense as the size that it's going to be for sitting on the top plate. And then I'll maybe take the faceplate and bend it up on end so I know information about the depth. And then I'll just use the rulers to go through and get some basic measurements off of these, and I'll transfer those then directly onto these cardboards and cut them out so that I can start laying out the different components that I have. This is really helpful for the gear that you already have, but for the gear that you don't have, let's say you've got a battery that you don't know the exact size of. Most of the manufacturers, you can go onto their website and you can get the exact dimensions for what their product is, and then you could just sketch it out, just measure it out, quickly cut that out. And now you can know, hey, is the 12 amp hour battery or the 15 amp hour battery, or do I need to go the 30 amp hour battery? What's going to actually fit in the equipment that I have? So this has proved to be a really helpful exercise. For me, it doesn't take very long to be able to lay out, but you can start getting a little bit more refined. And then you also have, at this point, you have the measurements of the different components that you have for building out your model. That brings us to the next level of taking this, and that is to perhaps to build out a virtual 3D model. Now, if you have a 3D printer, this can be super helpful because you can then print out some of the internal components. You can really start to see what things will actually fit next to each other, and we'll step through the process. I'm going to actually walk you through here in just a few minutes how to get started doing some basic modeling with some free software that you're able to download and use. And I'm going to show you where I'm at currently with my design, and then we're going to step through the process of getting you started using some of this 3D software on your own. And the software we're going to use is actually Fusion 360. I know it's a very expensive program that's available for professional use, but if you go online and you bring up your search engine of choice and you type in Fusion 360 for personal use, the very first link will take you to a page that you can get a free license for Fusion 360 for personal home use. And it's really targeted hobbyists and home use. And I'm going to show you how to use that right now. So let me switch over to my computer. Now this runs on both Mac and Windows. If you're running Linux, you can either run Wine to be able to get it to operate, or there's a bunch of other 3D programs that are out there. The specific tool doesn't really matter. And as you'll be able to see, a lot of the techniques that I'm going to use are really simple and straightforward to be able to do. So this is the current design that I'm working from. And I'm just going to just kind of drag this around so you can start to get a sense of the type of the GoBox that I'm looking to design and looking to build. I've got the volume of the space here is pretty much set for what the inside volume of the box that I've gone ahead and selected. So I just measured out what the inside portion is. And when I measured it, what I was measuring was the body of the box, not counting the lid. So there's got this lip that goes around on the inside of the box. And my plan here is to create a plate that fits right into the top of that, and then an insert that fits into the middle of it. And all of the components will go inside of that insert like this. So if we look up here at the top of it, this is a rough model of the head unit for my particular radio, which is the D710G. And you can see I didn't get super precise with it. I didn't do little cutouts or anything like that. But I'm going to show you how to be able to do this type of modeling here in just a second. I also modeled up a signal link, so you can see the way that looks. And if you flip it up on the bottom, you can even see that there's the ports are on the bottom of it. So as I was stepping through this process, one of the things that I found pretty quickly when I was looking at one of my other batteries was that when I would lay out the batteries and lay out the signal link in there, suddenly the signal link was overlapping with where the bottom of the battery was, and I wasn't going to be able to plug the thing in. So I had to redesign and move things around a little bit. The bottom here is a model of a Bioenno battery. This one happens to be a model that I built for the 15 amp hour battery. And it's just a cube. It's just a box that's based off of the dimensions on their website. I don't actually own this particular battery. I own some other batteries, but the other batteries that I had didn't quite fit in or have the right kind of power requirements that I was looking for to go in the box with it. I modeled out the body of the Kenwood D710 G, and I just put some basic holes in it so I can see. Actually, let me turn off the top layer here so we can investigate this a little bit. I'm just going to go ahead and turn off the top there, and you can look down inside, and there's a hole for where the microphone port is. If I spin it over on its end, let me turn off the outer body of this thing also, so it makes it a little bit easier to see what's going on here. And I'll zoom in on it. I just did a couple of little models of the back, so I knew roughly how much the back of the components would stick out of there, so I can know where my cabling is going to go. This back area here, this is a very rough model of the Microsoft Surface Go that I use as my computer. And I'm literally just thinking I'll just cut a hole inside of that computer. And when you start thinking about one of the big problems that I noticed in my previous designs I was using, I was having heat problems. So I wanted to really think through, like, how am I going to allow the heat to dissipate out of here? So if I turn off the computer out of the layer, you can see there's this hole that's going to be cut in the top where the computer will slide down in, and the D710 is going to have its heat sink right up against the back of where that hole is going to be to allow the air to escape out. And then I'll have another hole up in the front up here for being able to access the microphone. I also modeled a little speaker, and I've been playing around with a couple of different speakers to be able to buy something that's going to fit inside of here. And then I went out in the garage and I found an old set of desktop speakers, and I just harvested the speaker from inside. And I'll just go ahead and solder on some connectors on here, and this will actually work really well. I've done some testing with it with the radio, and it sounds really good. So using some reclaimed material from there. So that's the kind of rough sketch that I'm working from. Now let me show you how to create and get started doing some of this modeling yourself. So what I'm going to do is I'm going to come up here to the file menu, and I'm going to just say new design, and that's going to open up a brand new sketch. And we're working in the environment of Fusion 360. And so there'll be let me orient you a little bit to the application. You've got some tools along the top, a toolbar like most any other application. You have this browser over here in the left-hand side. This is kind of like the build order of all of the different components that you're working with. We'll call it that for now. Over on the right-hand side, there is this little floaty globe or cube, and that allows you to orient to the different faces of your 3D model. We'll explore with that. Down here in the bottom is a lower toolbar that we will go over some of the components that are there. That's kind of the basics of orienting yourself to this application. The first thing I'm going to do is I'm going to come up here, and on the top level of my browser, I'm going to right click and I'm going to add a new component. Now, what's a component? It's some particular part. And in this case, I'm going to say a new component, and I'm going to just give it a name. I'm going to call it the GoBox plate. And this is going to be the top face plate of the GoBox that I'm going to build. I'm just going ahead and type that in and hit OK. And it doesn't look like anything's happened. I've just got a structure that I can work with here. I'm going to come up here on the top, and there's a button here, the very first button. So it's likely the first thing you're going to do is create a sketch. So I'm going to start with creating a sketch. And you see this little icon that shows up here in the middle. This is asking you, where do you want to put the sketch? So I'm going to go right here in the corner. I'm going to put that down on, I'm going to click that plane. All right, I've got a sketch that's set up here. What am I going to do with this sketch? Now I'm going to lay out the size of what my plate actually is. So I've got some notes here for myself. And the plate I'm going to use is a rectangle. Super simple. I'm going to come up here. Notice the toolbar has changed. We're inside of a sketch now, so the icons that were there are different. We're in a different context. So this is our sketch. I'm going to come up here. I'm going to select the rectangle tool. I'm going to go down right to the center to the origin, go ahead and click and drag out. Now, as soon as you start dragging out, you'll notice that we have these little indicators that tell you how big this thing is. So the y-axis is selected. And I'm just I know my y-axis, the size of my plate needs to be 170 millimeters. I went ahead and measured that. So I'm going to type in 170, and then I'm going to hit the tab key, and it automatically selects over to my x-axis. And I'm going to type in 300 because I know 300 millimeters is the size of that axis. I'm going to hit return, and I'm just going to pinch in to zoom out and just kind of pan around. Now, when I'm dragging around on the computer, I'm just using 2 fingers to drag the object around on the screen. If I want to rotate it around in 3 dimensions, I also hold down the shift key while I'm using 2 fingers to drag around, and that works for that with a trackpad on a laptop. So here's my plate, and let's make this into a 3D object now. And you do that by we're going to learn the first keyboard command that you're going to use with this. And there's not too many keyboard commands. The first one's super easy. We're going to hit the Q key. Q is going to be push pull. And what it's going to do is it's going to flip that sketch around a little bit. And we have to select what thing we want. So we want to select our sketch. And over on the right-hand side, there is a little an indicator here that's got a value selected. And we're going to say, how big do we want this? How thick do we want our plate? We want it to be 5 millimeters. Is that a great thickness? I don't know. I'm just getting started with this stuff. We'll go ahead and type in 5. We'll hit return. And suddenly we're back in the 3D view. So if I hold down the shift key and I kind of pan around with my fingers, you can see we now have a little plate. And this is the right size for the top of the box that we're working with. All of that is pretty simple, pretty straightforward to be able to do. The next thing we're going to do is we're going to go, let's go ahead and cut a hole in the top of this, because we're going to have some different objects that we're going to add into our GoBox. And this is kind of like taking that first sketch that you have and taking it to the next level. And let's start with just a round hole, because we're going to need a round hole to maybe put our antenna connector in the top of this thing. So in order to do that, if we go back over to the browser on the left-hand side, you've got your GoBox plate. That's that component we created. We'll click the little drop down next to that, and we'll find an area for sketches. And we're going to go back to that sketch that we just made, because we're going to add a little stuff to the sketch. So we're going to go to the sketch. We're going to right click on it and say edit sketch. And what it does is it takes us right back into our sketch. I'm just going to pan up and kind of zoom in on this just a little bit, so it's centered up for us a little bit better. Now we're going to start off with a round hole. That should work pretty well. So I'm going to come over here, and here are my sketch tools. I've got my rectangle, which we've already seen, and I've got my circle. I'll click on the circle. Now, when you define a circle inside of this tool, you define it from the center of the object. So you just click to set the center point and then drag out. And what it's asking you is, what's the diameter of that circle? Well, I know that for an SO239 port, that is roughly about 15 millimeters, because I just took my ruler and just put it on the back of my radio and just measured it up. Okay, it's about 15 millimeters in diameter. So I'll type in 15 and hit return, and I've got my circle there. So that's pretty helpful. Matter of fact, I can go ahead and add a rectangle here. So we'll add a little rectangle on there as well. Maybe we'll make a place for the speaker to go. I'm just going to click and drag that box out. And I'm not really sure the size of that, so I'm just going to let it be kind of the specific size that it's chosen to be. All right, so I've got a circle and I've got a rectangle on this plate. Now what we're going to do is we're going to go ahead and just finish this sketch. I'm going to, up in the right-hand corner, I'm going to finish the sketch. And it doesn't look like anything's happened. Nothing really got selected here. There's nothing really special about what we did. But if you look down, let me actually take myself out of here for a second. If you look down in the lower left corner, one of the things I said down here is the timeline, or is the another toolbar. And this is actually a timeline, and it's showing you the different components that we've done. So here's our sketch, and then here's the extrude, where we took and we made that plate a little bit bigger. So if I right click on the extrude, I can edit that feature right there. And now you can see we're looking at the sketch, but we can also see that circle and that rectangle that we just created. So I'm going to select the circle, meaning it's deselecting the circle from the original extrude. I'll also just click on that rectangle and it'll deselect that from the extrude. And that all looks good. I'll go ahead and click OK. And now we have holes that are cut right through the top of that plate. That's all pretty easy to be able to do right there. So we've seen how to extrude an object, and we've seen how to cut a hole in it by simply just taking that sketch and being able to move it around. Now, it would be nice if this hole for the antenna port was over in this corner where we wanted it to be. And I know this is a 15 millimeter hole, and let's make it so that it's kind of pushed over to the side a little bit. Maybe we'll make it sit 20 millimeters off of each of these two sides. Well, that's super easy to do. I'm just going to come back over here to my sketch, right click on the sketch again, say edit sketch. And now here's the second keyboard command. Let me bring myself back onto screen. Here's the second keyboard command that you need to learn. The first one was Q, and that's going to be the push-pull or the extrude tool for you. The second one is called D for dimension. And this is one that in the type of modeling that we're doing, you're going to use a whole lot. So I'm just going to press the D key on my keyboard. And when I do, you'll notice that I'm able to kind of move over top of some of these different objects. I'm going to move right over the center of this. And when I click on the center, my cursor turns into a little 2 vertical arrows. And now I'm going to come up to this top edge. And I'm going to click on that. And then I'm going to pull back towards the 2. And you can see there's a number appearing. I'm going to click in there. And now I'm going to enter in what's the dimension from the center of that circle to the edge of that top piece. And we said we're going to put it 20 millimeters. So just type in 20, hit return, and that circle jumps to that point. Well, now let's do the same thing. We're going to make this circle 20 millimeters off of that one. So once again, we've got our D key is still selected. We click on the center, we come over to the edge, click on the edge, we come back just a little bit and we get the value that's there. Oops, wait a minute, cancel. I didn't get my selection there. Sometimes you got to do that. You just hit escape to be able to cancel out of there. I'm going to click on the center. I'm going to come over to the edge. I'm going to come back. There's my line that's looking in the right way. Click on that, and I'm going to type in 20. Boom, that circle just moved right over into that specific location. I'll hit the escape key to be able to stop editing, and I'll finish my sketch. And that brings us right back to the 3D. And now the hole in our plate is in exactly the right spot for our antenna connector that we want to have. Now that's pretty fancy. What if we want to add some other object that we want in here? We can extrude up even further. So let's come back over to our sketch one more time. We're going to edit the sketch. And this time I'm going to draw another rectangle. And I'm just going to put a rectangle up here. And maybe this is like a faceplate or something that you're doing. You don't have to get super fancy with this. I'll go ahead and I'm going to say that's 150. Just type that in, hit the tab key by 30 millimeters. The value doesn't really matter right here, right now. And so I've got my new rectangle here. That keyboard command for extrude, remember that Q? I'm going to hit Q again. Takes me back into this extrude mode. I'm going to select the new rectangle. And once again, notice there's this little blue arrow. If I can kind of zoom in here on it, there's actually a little blue arrow that's showing where we're going to do that extrude. I'm just going to click that and just kind of drag it up. And as I drag it up, initially, it shows in red as if something's not right. If it's showing up in red, it's showing you that, hey, I'm going to make a hole in here. And if you look over in the extrude panel, it's off to the side, we can see that the operation is going to do is a cut. I'll click that and just say, don't do a cut, do a join. And I'll click on that join and just say, okay. Now, it doesn't look like anything happened. If I come back into the lower corner, you can see in my timeline, there's a little ghost of an icon. This is one of the things that's kind of a little weird with this. I'm going to just move my little playhead over one, and there is that new object that I just extruded up. So with just a few minutes of going in and playing around with Fusion, you can get in and you can start to come up with some different models for how to build your specific components, start to lay them out. You can use some of these tools to be able to just move these objects around by using that D key and redimension. There's a lot of other components that you're able to use in here, but I don't want to get too crazy with it. I think right now at this point, you've got just enough to be able to get in and start laying out maybe how you want your faceplate to look, or how you want some particular component that you want to be able to use and create. And we're going to be coming back to this program in future episodes, and we'll show you how to get in, and I'll give you a sneak peek as to some of the components that I've been using. I'm going to click this little waffle icon up here in the top. That opens up the side browser. And I've already gone in and I've modeled a few of the different batteries, say that Bioenno cells. Here's the GoBox that I've been working on. I've also modeled the KX3. This was the first one that I started off with. I'll go ahead and just double click that. That opens this up as the model that I've designed out here. So you're able to go in and figure out kind of the real important things is to make sure you get the size right and make sure you know where the ports are for the particular components. So just looking at this KX3 with what I just showed you, I made a sketch that's the right size of the top of the faceplate. All of the knobs here are simple circles that are on that sketch that have then been extruded up. The buttons are little rectangles that have been extruded up in order to get a sense of what this thing actually looks like. You don't have to get this detailed. You can start off with literally just a box, and I'm going to show you a couple of those other models that I've built. But this has proved to be really helpful because I can then go in and I can see the different components where I lay something out inside of a box as to where it's going to work. Let me come down and look at a couple of the other models that I've sketched out here already. Here's the model of my Kenwood D710G body that I've been working on. And you can see this is literally just a pretty big box right here on the top. And on the back, I modeled out where the different ports are just so I can get a sense as to how far those components stick out and roughly where the connectors are. So as I place them inside of the overall virtual box, it's really going to inform what kinds of cabling I might use, what kinds of connectors I might use to see how I'm going to route all the wires and so forth. I also modeled the heat sinks that are under here. These are just done with a cut, very similar to what we saw already. There's the port for the head unit. And so a pretty simple model. I'm sorry, that's the port for the microphone port. This is the port for the head unit over here. Let me go over to a couple of the other models that I've done here. Here's the head unit for the D710. And each of these only took a couple of hours to be able to just kind of sketch up. And I'll make a lot of these available on the WaveTalkers website, so you can get in and you can kind of play with these models as well. This one was a little more complicated. I did a couple of little cutouts to give me the sense of the shape. I made the screen here, and these are just circles and rectangles for the buttons and knobs in order to get a sense as to how that looks. Let me come over and look at the signal link. I modeled up the signal link for us. So that's also ready to go. Now for the signal link, I went ahead and made a graphic that's overlaid on this front face. So it really does look like a signal link, and all of the knobs and buttons are there. And all of these are to scale so that you can drop them into your drawing and you can start to get a sense as to how those look. And I'll show you how to do that before we wrap up. I also modeled a couple of the speakers. This is a speaker that Dan had suggested that he's using, and I went ahead and picked up one of those. So I quickly modeled what that would be, so I can see how that's going to look on the particular GoBox that I'm working on. And then this is the random found from the crap in my garage speaker that I just have, so I can see how that fits in. And this one actually is, I think, the one that I'm going to end up using because it's a little bit smaller and it's got really nice sound to it. So let me come back up here to the model that we were working on. It's going to take me a second to find it up here. Let me close a few of these tabs at the top. And I'll just show you very briefly how to place one of these other objects. So let's say I wanted to place that the model of the Kenwood. So I just open up the drawing that I've got. I've imported these other drawings that I've done. I'm just going to right click on the thing that I want to insert and say insert into current drawing. Oh, wait a minute, I got to save the drawing first. File, save. And I'm going to call this WaveTalkers demo. There we go. Now I'll do that again. Right click on the object I want to insert into the current drawing. And it brings that in Now I can simply just come in here and use these little move tools to click and drag this up a little bit. Maybe I'll come to the right a little, drag it over, drag it up a little bit higher, drag up. And that's kind of the placement that I want for it. I'll say okay, and now I have the model of the head of the radio, so I can start working with that inside of the model. So I'm going to stop there at this point. I hope that gives you just a little bit of a sense as to what's possible using the free version of Fusion 360, and to start to get yourself set up with that. I'm just looking over in the chat and I see some folks. There's a lot of pre-made models that are out there. One of the things that you can do, you can go on to places like Thingiverse and Yegi. There's a whole bunch of them. You search for 3D models, and there's a bunch of things that have been modeled that are available that you can then import into the program and use. I did a lot of that where I was kind of looking at some of these different options. Initially, yes, my AirPods are nearby. That's wonderful. Thanks. But I found that there's not a lot of radios that have actually been modeled that are very precise. There's stuff that goes on to the radios, but not the radios themselves. And so that's where I've started to go ahead and build some of those. And I'll make a lot of these available to folks to be able to go in and use in your own designs and so forth. So
yeah, one of the things, Chris, that you didn't say that's very important is that it's just a couple of steps from where we're at to where you can send this to your 3D printer. So if you had designed this faceplate to go on your plastic box, once you have it the way you want it, you send it to your 3D printer and it will print it as you've designed it.
Yeah, so if I take this design right here, I'm going to go ahead and save again. I'm just going to press Command Control S to be able to save. I'm going to say, yeah, user saved. I'm going to come up here to the file menu. I'm going to click the drop down menu and look at that right here, 3D print. There is an option now inside of Fusion 360 that if you've got a 3D printer, if you've got access to a 3D printer, you can export out the model directly, and it's got a slicer that's built in. If you know what that is for 3D printers, you're all set. A lot of libraries, a lot of places, you may not have your own 3D printer, but there may be somebody in your group who has one that would be willing to let you work with that.
And as you said, libraries, a lot of libraries have them now. In major cities, most major cities, there are maker spaces that you can either rent time at or join and have access to 3D printers and other neat stuff.
I will say, as I'm thinking through the overall box that I'm designing, one of the challenges that we've been doing this back and forth with David and with Dan over the past couple of weeks, as we've been talking about all of these components, and I've been watching David go through trying to build out all of those additional Go boxes that he's got, and it made me think about one of the challenges that I keep facing with the little ammo can that I have is, once you start putting stuff in the box, it's real hard to get in there and get access to the stuff that's there. And so my plan is to actually have this, what is this kind of like clear yellow or clear orange shell will actually be a lift outable shell. And I'm going to put mounting brackets that I can 3D print right into that shell for the different components. And then I'll just simply use the same technique that I use to cut away the holes up here on the top, and we'll cut away any of the extra space that's not needed, so that it just ends up being essentially a frame that it's a custom frame for my particular gear that I can then pull out and make all of that stuff work. So we're going to revisit this many times. If you find this information something that you want us to go in more depth, let us know in the chat, either on YouTube here inside of the Zoom, so that we know kind of what your interest in this is, so we know how deeply to go into this subject. I think one of the things that a lot of hams are into is making your own gear, and we'd like to be able to help bring those tools available to you and make it more approachable for all of you to be able to do that as well. So with that, let me disconnect this computer. Let me see. Let me go back to the slides for a second. Disconnect this computer and bring where did I put my Surface? Where'd you go? There you are. Because we're gonna do we're already at the end of the hour, and I do want to bring up, before we wrap up and do all of the closing things, we're going to check the map. So if you haven't sent in your Winlink check-in, go ahead and send in your Winlink check-in now. But in the meantime, I know we have Steve Waterman with us, and he is asked to be able to, he's got a little announcement for us. So let me find Mr. Waterman. There he is. And make him so that he's able to unmute himself. There you go, Steve. You want to be able to turn your camera on, and we can pin you up to screen.
Hi. Good evening, good afternoon, or whatever time it may be. Very interesting what you're doing there. Top of my head's not right. At any rate, about drop kits, it's better to have too much than too little. Better to be too heavy than too light, because once you get somewhere, it's sometimes hard to get out of there, and better to have to lug something that is unwieldy than to not have it there available. So I understand how all of that works. It's also really a lot better to have a, if you can afford it, shock mounted, rack mounted drop kit that has your equipment put in through cable ties rather than bolted. So if you need to, you can get it out of there and get something else in to replace it. Okay, enough about drop kits. I just wanted to let you guys know that we have reached a, let me turn this radio off, please. We've reached an agreement with Jose, who is the author of Vera, and we are going to add a redundant backup protocol to Pactor 4 on the Sister Shares network of Vera HF. Because it's redundancy is important, including protocols. That should give people an opportunity to get involved without having to spend $1,800 on a modem. And it still requires an agency sponsorship. In other words, hams just can't jump into that program. They need to be sponsored by an authority having jurisdiction or some critical infrastructure partner, like maybe Huntington Hospital in LA or whatever. But I wanted to let you guys know that, because that's going to greatly increase the capability. I sent my second check-in report tonight over Vera, this afternoon over Vera HF from Nashville, Tennessee to Fairbanks, Alaska, and hopefully you got it. I got a copy of it here, using 100 watts with a 30 foot off the ground with a 130 foot piece of wire with a 130 foot counterpoint in fed. So it doesn't take a lot. It's very robust, as a lot of people here already know. And I'm working with Masters Communication to have their products all enclosed with the proper connectors, and to have their mixer a little bit more robust. When you have two separate protocols or audio lines coming in to one radio, if you do not have an internal sound card, you need an external sound card and something to handle, if you're using multiple protocols, the audio coming in simultaneously from those multiple protocols. So that's all being handled, which is all going to be announced on the end of the month shares working group. And I would encourage anybody that has any interest in emergency communication to find a nearby agency and get them to sponsor you so you can get a call sign and participate. It costs them nothing. It's a benefit to them. And if you're already involved, it costs you nothing. And it gives a lot. Hopefully you'll never have to use it for real, but if you do, it'll be there. That's about it, Chris. Thank you.
That's very exciting. VARA HF coming to shares or available to shares already. That's a huge, big announcement that's there. And thank you very much for sharing that.
Steve, there may be folks on here, I'm sure there probably are, that don't know what shares is. Can you give a real quick description?
Yeah, the Winlink, as you know, is on amateur radio. And the best I could describe it is you have an iPhone and I have an iPhone, and we both use the cloud, Apple Cloud, but you don't know I'm there and I don't know you're there. Winlink encompasses a lot more than amateur radio. It encompasses Canadian military, it encompasses our DOD and our DHS, and many, many authorities having jurisdiction or civil authorities at all levels of government and all levels of critical infrastructure partners like AT&T, et cetera. And other countries likewise. In our country, we have a Winlink system called the Department of Homeland Security, Cybersecurity Information Security Agency, National Coordinating Center for Communication Shared Resources. And that is a system that uses NTIA frequencies, not FCC frequencies, which means that county and state governments and critical infrastructure partners can use non-expensive commercial type accepted equipment. They can use amateur equipment that's been opened up on these federal NTIA frequencies, which cover from 3 all the way up to way past the current maximum usable frequency. There's a network up there, a Winlink network, with over 100 radio message servers that are active that scan 5 frequencies each that cover the United States, Puerto Rico, Virgin Islands, Hawaii, and other places. So there's no Part 97 restrictions about encryption. In fact, it uses on Pactor 4, it uses the government standard AES 256 transmission for encryption. That's the process that encrypt that the messages go through. You don't have to have encryption. The encryption was built into the modem, and if you're a radio message server, you have it. And if you want to pay $199 as an agency end user, you can have it. And there's no other similar restrictions like there is in the Part 97 service, which is really not an emergency service. So this is a true emergency service, and it was set up specifically for this purpose. These frequencies are ours to use exclusively. We're not sharing them with anybody that legally anyway. And it's just a terrific opportunity for an amateur radio operator to assist their nearby authorities by doing the same thing they're doing now, only having voice and data frequencies that are much more diverse, and a regulatory environment that is much more lenient. Does that help?
Be clear, this requires a whole separate call sign. It requires a whole separate, so it's not something that's just because you're a ham you necessarily get access to. You have to be partnered with a particular agency who then works to get you the call sign.
Yes, you don't even have to have an amateur radio license. A cop doesn't have to have an amateur radio license to have an FCC unit frequency. I mean, call sign. So Yeah, these are separate call signs. It's sort of like Mars, but it's not like Mars. It's just a separate entity. There aren't any rigorous ladders to climb. It's great that you have the 4 ICS courses and beyond if you can get them, but nothing is mandatory other than signing one piece of paper as a non-disclosure and having your agency sign with you. That's all it takes.
Awesome.
Yeah, we did it for Los Angeles City, and really the only difficulty we had was getting the attention of the right people within the city to get them to sign the paperwork and forward it. But we relatively quickly had 5 shares licenses, and we've got it set up and running, and we've got some additional equipment coming. And so it is very doable. If
Are you
can
in,
get
you're
your
in LA? Dan?
LA City, yes.
Yeah. Okay. Well, LA County, Skip Bloomer also has, with the sheriff's office has it. Orange County, all counties. There's 72 grantees to your to the $6 million program that Cal OES just offered, and there's 72 grantees. So California is going to be loaded with its stuff. But so are other states. If anybody's got an interest in this, you're welcome to contact me. I don't know what I could tell you that I haven't already, but maybe I know some agencies that are nearby that you could get associated with. Maybe I don't. If I do, I'll be happy to point you in that direction.
Cool. Thank you very much, Steve. Really appreciate that. Let's wrap this up. I want to before we go up and show the map, I want to show if you have downloaded, if you have the checkbox set to get the latest beta versions of Winlink, there's been a new button that's been added up here in the toolbar. The way that you use it, and Bill, I hope you don't mind, I'm going to pick on you. You just select a Winlink email that's come in, or Winlink message, make sure it's selected, and you're just going to come up here in the toolbar, and just to the right of the globe, there's this new like teal colored box. You go ahead and just click on that. And what it does is it brings up a map and shows you exactly where that user's Winlink station is located, and brings it up on the map. So you're very quickly able to identify.
Put the cursor on the pin.
Oh yeah, it's right there, and all their information is right
now.
there.
Right click on it.
You can print report, copy the report to the clipboard, and or cancel it. So a new thing for folks to be able to play with and be able to check out. You do need to close the map window, and then you can go on to the next message. So a nice new feature. While we're there, I'm going to go and do one more quick check. I'm going to open the session, check and see if any additional messages have come in. I've been checking throughout the time here. It looks like no new ones have come in. So let's bring up the map and see where folks are coming in from today. We're going to select the Winlink check-in forms here. I'm going to go ahead and display the map. And I need to come up here to the set filters, and we're going to only show the data for the last 24 hours. Go ahead and hit save, and let's blow that out to full screen. Looks like we've got Terry down here in ZL land that's joining us. Hey, thanks, got your check-in, Terry. Looks like over here in Hawaii we've got Bill KH6UU. Thanks for joining us, Bill. Up here we've got Roland joining us from Germany, and Franz joining us from Austria. Hey, thanks a lot for joining us. Let's go ahead and zoom into North America here, and again, to pan the map, you just hold down the right mouse button and click and drag with your left mouse button. And
I don't see me.
Don't see you for some reason. I did see a shares call sign that checked in, and when I mapped it, it showed up in Indiana, I believe. So
it's not me.
Not you.
I got Steve. I got 2 check-ins from Steve.
Right.
Yeah.
Yeah, we'll look and see what's going on with that. We've got down here, it looks like we've got John down here in the Houston area, some folks here in Georgia and South Carolina.
Maybe I screwed around with testing something and forgot about it.
Yeah,
Can
I
you
think
check
might
that
have
They
in,
been
they
Dan?
show up
somewhere
on
else.
both of the check-ins that I got from Steve show up in Nashville.
Okay, good.
They
W9 and
map if you
WN.
hover on them and they map. Sorry, Chris.
That's all right. Where was it that I saw you? I thought I saw one mapped for you, Steve. Anyway, we'll just kind of click around here, see where some of the folks coming in from the Northeast are. A few of you guys that are showing up there in Colorado, Ohio. We'll come down the Pacific Northwest and see some of the other stations that are coming up in here. Make sure everybody is showing up on the map. We really appreciate everybody sending your check-ins today and making sure that you're here. Let me zoom in a little tighter on Southern California. More folks coming in there in the Southern California region. Folks coming in from Vegas and out there. There's Craig, KJ6IJJ. There's Logan joining us, and some folks here in Ventura County along here as well. So thanks everybody for checking in. We really appreciate everybody doing that. And if you find the things that we're doing to be really helpful, you can really help us out by going on to our YouTube channel and like the videos, subscribe to them there to really help the content be shared out to other users, even if you're here inside of the Zoom. If you find it really helpful, consider going on to WaveTalkers.com and using the Buy Us a Coffee link to help us support all the infrastructure that it takes to keep this show up and running. We really appreciate that. We did have some Wave Talker stickers that were made up. We're going to be sending these out to all of the folks that are the supporters on the Buy Us a Coffee link, and those are all being stuffed into envelopes now as we speak, so that those can get out. So hopefully they'll get them out to you here shortly. With that, let me bring the guys back up to screen.
When you get to the Arctic Circle, you can put that on the back of the sign.
Yeah. Go ahead and bring those up. Add spotlight. There we go. And Dan, any closing thoughts for you for today?
No, while planning and all that's important, getting something done is important. A GoBox can be, or GoKit can be as simple as a radio screwed down to a cutting board, something that you can grab and go. One of our ACS members has done that for years, and he finds it just extremely flexible. He can slip it onto the front seat, plug it into the cigarette lighter, or in his case, he's got power poles wired right off the battery, but he can run it in his car. He can take it with an external battery and put it on a table. So what's the saying? Don't let good be the victim of excellent. Just think it through, make something. And if you need to improve it along the way, you can always do that.
Yep. Good advice. Dave, any thoughts from you today?
So I agree that the way I heard that saying, Dan, was don't let perfect be the enemy of getting things done. And I think, the reality is I've had a lot of GoBox. They multiply like HTs do. A lot of it is very much purpose driven. And it's, in terms of driving, I drive my GoBox lots of places, and there's stuff in there that I wouldn't want to carry around, and in fact couldn't carry around. Is it always effective to bring everywhere? No, that's why I've built other ones that are portable. It's really thinking about what are you going to do with it? Where are you going to use it? What do you need it to be able to do for you? And I'm very much like the modular approach. While some of the boxes I showed you guys earlier and I've been working on have batteries built in, I personally don't think that long term that's the way to go. It's a 2-box approach for me, and that way I can size whether I grab a small battery that I can tuck in somewhere, or I grab the big toolbox I have that has 90 amp hours in it that I can carry its lug around, but I have it and it's available. A lot of it depends on how long I'm going to use it for, how far I might have to carry it, and what are the sources I'm going to have to be able to charge it to continue making sure that I can serve the agency that I'm working with for the period of time that they expect to do it. So more to follow, more to come, lots more.
As I start really thinking through, as I've really just recently gotten involved, so I am by far not an expert in the 3D design software to be able to get in and play with that. But what's really tweaked my interest is that I've been able to very quickly be able to build some basic models, and now my brain is just constantly thinking of new different projects that I may want to do related to amateur radio, related to the overall setup that I'm doing, and using the GoBox has been just an excuse for me to get in and start learning the tool to then start modeling out maybe some different antenna components that I might want to do, or maybe some other different gear that I don't quite have or couldn't afford right now, that I may want to think through, how would I build this, how would I integrate these, and the tools become really achievable. I was really surprised as to how much more accessible these tools are than I ever thought they were. All of us now have 3D printers, and so we are going to be doing some more shows coming up with integrating 3D printing and 3D components into our overall kits, and lots more of how to use this, how to integrate it, how to then take some of these custom design projects and work with them inside of Winlink, work with them inside of ham radio, or using other different components. So we're really excited for 2023 and all the new content that we have coming out. So with that, I think we'll say 7-3 to everyone. We'll wrap up the live stream. If you're joining us on YouTube, please do go ahead and like and subscribe if you haven't already. And then for folks that are joining us here inside of the Zoom, hang around for the after party, and we're going to take your questions and unmute the mics and have a chat for a little while. So thanks for everybody who joined us online on the different channels. I'll go ahead and say 7-3 and turn all those off. We'll see you next week.